I'm Anil Kumar. Welcome to my series on functions. Here's a worksheet in which we are going to find inverse of function from given equations. Remember, inverse may or may not be a function. So here we have three examples with a lot of parts. This will, I hope, give you a lot of practice. You can copy these questions, work them out, and then look into my suggestions. In question number 3, we have taken some relations which are not functions, and we'll see how to find inverse of these relations also. So let's begin with the very first question here, which is state if the given functions are inverses. 4 examples. First one, f of x is 2x minus 1, g of x is x over 2 plus 1. Is this a function? We can figure out in different ways. One of the method is reverse operation. The statement says that multiply by 2, then take away 1. Reverse operation will be to the x, we add 1 and then divide by 2, right? So that should be the inverse, right? So which will give you x by 2 plus half. So in this case we have x by 2 plus 1, so it is not an inverse, right? So let me rewrite this as not an inverse. Clear? The second example we'll again do with reverse operation. F of x is 3 plus x cubed. That means you're adding 3 to cube. So the inverse will be the reverse operation, which is you subtract 3, right? So x minus 3, and then you do cube root, correct? Which is what this is, which is g of x. So this one is yes, it is. So this is yes, right? C, x squared minus 3 and gx equals to this. Now here, if you do algebraically, you'll get the same relation. However, there is a catch here. When we have this function x squared minus 3, let's look into this. F of x is given to you as x squared minus 3. So that is a parabola which is opening upwards, right? So here, as you can see, domain is x belonging to real numbers, and the range is y is greater than equal to minus 3, correct? So therefore, f inverse x, if it is a function, first, since it fails the word horizontal line test, so inverse is not a function, okay? And secondly, as far as the inverse is concerned, then the domain of inverse will be what? Will be what was the range, right? They flip. So the domain should be x greater than or equal to minus 3, and range will be y belonging to real numbers. Now in the given function, square root x plus 3, we get that the domain is okay, x is greater than or equal to minus 3. However, the range is not matching, right? So truly speaking, the inverse of this particular function, I should not write x like this, it is not a function, will be plus minus square root of x plus 3, right? You get the idea, right? That is going to be the inverse. So this one is not inverse. And inverse is not a function. So let me write down which is not a function. Clear? Here, let us figure out the inverse algebraically, and then we'll confirm whether g of x is an inverse or not. So to find the inverse, the steps are we swap x and y. So we could write this as x equals to minus 1 over y plus 1. We'll just multiply, cross multiply. We get minus 1 over x. Take 1 on this side. So we get y equals to minus 1 over x plus 1. Okay, so let's do it on the right side. So that gives you y equals to minus x plus 1 over x. Now, in this particular case, if I want to write in that fashion, which is minus outside, I'll get minus here, right? I'll not get plus, correct? So this one is not the inverse. So inverse for this function will be minus of x minus 1 over x, not plus 1. And therefore, this is also not inverse. Correct? So only one of them is the inverse of the function. The other three are not inverses of the functions. C fails because the domain range is not matching. Perfect? Now let's take question number 2, in which we have many examples, and that is a major part of this video. So many examples. We'll do them one by one, beginning with a linear function. So the strategy to find inverse is write the function as y equals 3 minus 2x. Next is swap y with x. So when we swap, we get x equals to 3 minus 2y. And then the step is to solve for y. So when you solve for y, we get 2y equals to 3 minus x. Y is 3 over 2 minus x over 2, which is better written as minus x over 2 plus 3 over 2. And we can say the f inverse x is equal to minus x over 2 plus 3 over 2. Correct? Now I could have found the same relation using the strategy of working reverse, right? So this really means you need to multiply the function, let me write here, by minus 2 and then you add 3. So the inverse will be what? From x, you take away 3, right? And then you divide by minus 2. Does make sense? So that gives you minus x by 2. Minus minus becomes plus 3 by 2. And you get the same result. Do you see that? That's what we meant when we did question number 1, part 1. Okay. Now let's take the second example, which is a quadratic function. Let's see how to find inverse of this. So first step is to swap x and y. So we'll write x equals to y plus 1 whole square minus 3. Now remember, we are given here that x is less than equal to minus 1. Now you should know that the y value in this case, it is a parabola which opens upwards from minus 3. So y is greater than equal to minus 3. So the inverse will have those things flipped. Is it okay? Okay. Now let's try to obtain the value of y. So we get x plus 3 equals to y plus 1 whole square. Now we have square root of x plus 3 equals to y plus 1. Now when you do square root, you will do both plus and minus. Now which one should I take? That is a big thing. So this parabola given to us is opening upwards like this. Now when I say that x is less than minus 1, we are talking about the left arm, right? Less than minus 1. So in this case, we'll take only the negative value. You get the idea. Not positive and negative. Since our domain for x is less than minus 1, so we have to consider the left side, the lower half, right? So that is very important to understand. And now you can take y on this side, because the minus 1 minus square root of x plus 3 is equal to y, or y is equals to minus square root of x plus 3 minus 1, or the inverse of this particular function is equal to minus square root of x plus 3 minus 1. Since we restricted the domain of the function, inverse is a function, right? And you will note that for this inverse function, you can see that x is greater than equal to minus 3, right? And y is less than equals to minus 1. That negative sign means open downwards. So it is correct. Do you see that? It's a good practice to write domain and range of the inverse functions also. However, I have omitted this in the questions seen here. We'll treat domain and range of inverse and the functions separately. Question number 2C. You can actually pause the video, answer these questions. The first one here is a linear function, and then we have a rational function. Now let us see how to find the inverse. So here we'll swap, we get y equals to 2x plus 6 over 3. So when you swap, you get x equals to 2y plus 6 over 3. So we have swapped, right? X and y. Now isolate y. So we get 3x equals to 2y plus 6. 3x minus 6 equals to 2y. 3 by 2x minus 6 by 2 equals to y. So we get the inverse as equal to 3 by 2x of this particular function minus 3. Correct? Let's do the next one. So here we'll swap and we'll write x for y and y for x to find inverse. So we get x equals to y minus 1 over y plus 1. Cross multiply. X times y plus 1 equals to y minus 1. So we get xy plus x equals to y minus 1. Bring them y's on the left side. So we get xy minus y equals to minus x minus 1. And now we can take y common. We get x minus 1 equals to minus x minus 1. And y equals to minus x minus 1 over x minus 1. Is that clear? And therefore, we can write its inverse as f inverse x equals to. Now you can write it in different ways. We can take minus common and we can write x plus 1 over x minus 1, right? We can do that. So that could be the inverse of this given function, right? So let's move on and take the next part of question number 2. This time we have a cube root function. So let's write, so function is y equals to cube root of x plus 5 plus 1. Now to find inverse, we'll swap. So we get x equals to cube root of y plus 5 plus 1. So we get x minus 1 equals to cube root of y plus 5. Now we'll cube this. We get y plus 5. Take away 5. So we get y equals to x minus 1 whole cube minus 5. And the inverse in this case for the function is x minus 1 whole cube minus 5. Perfect. Now in this particular function, cube root has no restriction. Both domain and range are all real numbers, so we need not worry, right? So here we know x belongs to real numbers and y also belongs to real numbers. So that is the domain and range. So no need to worry. But in the next example, where we have y equals to square root of x minus 3, now in this case, x has to be greater than equal to 3, correct? And we know y is greater than equal to 0 for the given function, square root x minus 3, correct? So if you sketch this particular function, what do you get? You get a parabola, you get a square root function which has moved 3 units to the right. Correct? If I substitute 3 here, 3 minus 3 is 0. Perfect. So that is the domain and range. Now let's do the inverse. So to do inverse, we'll flip x and y. Correct? So when you flip, note that now the x value will be greater than or equal to 0 and y will be greater than or equal to 3. It makes sense, right? Y has to be greater than or equal to 3. Otherwise, within the square root, you'll get a negative number. Does make sense to you? Correct? So keep that in mind. So now we'll square both sides. We get x squared equals to y minus 3. So we get x squared plus 3 equals to y, or f inverse x equals to x squared plus 3. Remember, x is greater than or equal to 0 and y is greater than or equal to 3. It is a must to write this domain and range. Otherwise, the parabola will not be the inverse of this function. Only one arm of the parabola is the inverse, right? So we're talking only of the arm which is kind of like this on the right side of x equals to 0. You understand? Not both the parts, right? So x greater than or equal to 0 is very important to specify. Question number 2G. Now here it is a very difficult question. We have okay. So what I will do is I'll just remove this bracket. Okay. So what we have here is h of x is minus 5x squared plus 20x plus 1. We need to find inverse of this function. How will you do it? Now for a quadratic function to find inverse, we need to write it in vertex form, and only then we can do it. So we'll basically rewrite this function in vertex form. So completing the squares is the method which I'm going to do. Taking minus 5 common, we get minus 5 outside x squared. Dividing this, we get minus 4x, right? And we'll keep this one outside. Now, half of 4 is 2. So we could write this as minus 5 x squared minus 4x plus 2 squared minus 2 squared plus 1. And that gives you minus 5 x squared minus 4x plus 2 minus 4 plus 1. Now first three terms are perfect squares, which could be written as x minus the number 2 here, right? So whole square minus 4 plus 1. This step was not really required. Let's open the bracket. So we get minus 5x minus 2 whole square. Open this bracket. So plus 20 plus 1. Or we get minus 5x minus 2 whole square plus 21. Correct? So that is the function. Now we can find inverse of this particular function. Okay? So the inverse will be, we'll swap x and y. So we'll write, so swap and then do inverse. So we can write this as x equals to minus 5 y minus 2 whole square plus 21. So let's do the operation. X minus 21 will divide by minus 5, and what we get is y minus 2 whole square. Now whole square means you do square root. So we do square root of this with plus and minus, and we get x minus 21 over minus 5 equals to y minus 2. Correct? So there's less space here. I'll just squeeze in the solution. So the inverse, which is y, is equals to, taking 2 on this side, plus minus square root of x minus 21 over minus 5. Or we can say inverse of this function. I'm not writing x since this is not a function. It has got both plus and minus values, right? So it should be written as 2 plus minus square root of x minus 21 over minus 5. Is that clear to you? You could write over 5 and switch these positions. But I'd like you to go through these steps and understand how to find inverse of a quadratic equation when given in standard form. Now here we are given the quadratic equation in factored form. Now let us see how to find. So we'll again write this in vertex form and then do our operation of inverse. So we have here as x squared minus 4x. That could be written as x squared minus 4x. Half of 4 is 2. So we'll get plus 2 square minus 2 square, which is x minus 2 whole square minus 4. Right? Now to find the inverse, we'll swap and then figure it out. So we can write this as x equals to y minus 2 whole square minus 4. Bringing 4 this side, we get y minus 2 whole square, square root will give you plus and minus, correct? And this is, when you find this, we get y minus 2, and the value of y will be 2 plus minus square root of x plus 4, or we can say inverse of this function is not a function, which will be plus minus square root of x plus 4 plus 2. Is that clear to you? So that is how we are going to get inverse of a quadratic function when it is given in standard form or in factored form. Note, in this case, in both the cases, inverse is not a function. Is it clear to you, right? The reason is very clear. This is, both of them are parabolas. Now this one is a parabola which opens upwards and it fails the horizontal line test. This one is a parabola and which opens downwards and it also fails the horizontal line test, right? So the inverse is not a function. Is that clear to you, right? Very important conclusion. Now here are two questions for you. We have already done similar kinds. So we did a cube root, this is the fifth root, and then we have a quadratic equation. I would like you to pause the video, answer these questions, and then look into my suggestions. So f of x is this. To find the inverse, we'll swap, so we write x equals to fifth root of minus y plus 3 over 3. So we can write this x to the power of 5 equals to minus 5 plus 3 over 3. Multiplying by 3, we get 3x to the power of 5 equals to minus y plus 3. Taking y on this side, we get minus 3x to the power of 5 plus 3. And that becomes the inverse of this particular function, which is minus 3x to the power of 5 plus 3. Now for all these videos, you could write domain and range for the function and inverse, right? So note, write domain and range for both function and its inverse. Okay, so that will be an exercise. Okay, so let's do the second question where we'll again do completing the squares and find the inverse. So let us first rewrite the equation in vertex form. So let's get it in vertex form first. So we have y equals to half of x squared minus 6x plus 2. Taking half common, we get x squared, and that becomes minus 12x, right? Plus 2. Half of 12 is 6, right? So we get half of x squared minus 12x plus 6 squared minus 6 squared plus 2, which is half of, we can write this as x minus 6 whole square minus, because this is minus, right? And here we have minus 6 squared, so we can write this as minus half of 6 squared is 36 plus 2. So that gives you half of x minus 6 whole square, and that is 18. So we get minus 16 here. Perfect. So that is y equals to this much. Now to get the inverse, we'll swap, correct? So let's rewrite this as x equals to half of y minus 6 whole square minus 16. And breaking this here, we get x plus 16 times this 2 equals to y minus 6 whole square. Now we'll do square root. So when you do square root, we can say 2 times x plus 16 with plus and minus is equals to y minus 6. And clearly, we can now write what y is, right? So we can write y as equal to, taking 6 here, we get plus minus square root of 2 times x plus 32, right? You could write it like this, plus 6. Now that is not a function, but it's an inverse, right? So inverse will be plus minus square root of 2x plus 32 plus 6. Is that clear to you? So we have to do completing the squares to get the equation in vertex form, and then we should be finding the inverse. Okay, now two more to go for question number 2, and that is we have a combination of a rational function and a square root function. Okay, so here we'll start with this step. We'll just swap, right? And then start. So get x equals to 2 times y plus 7 over y minus 2, cross multiply. Xy minus 2x equals to 2y plus 7. Bring y's together. Xy minus 2y equals to 2x plus 7. Y is common. X minus 2 equals to 2x plus 7. So y is equals to 2x plus 7 over x minus 2, or f inverse x is equal to 2x plus 7 over x minus 2. Now in this function, it is very important to understand that x is not equal to 2. So we're talking about that the domain and the range, and y is also not equal to 2, since 2 is your horizontal asymptote. Is that clear to you? So therefore, in the inverse also, we get, when you swap, we get the same condition, x not equal to 2 and y not equal to 2. Correct? Okay, let's take up the next question. Swapping, we get y equals, first we'll write as such. Replace the function by y and now swap. So get x equals to 2 minus square root of y plus 5. And then that gives me x minus 2 equals to minus square root of y plus 5. Dividing by minus means interchange the signs. Now we'll square, so minus x plus 2 whole square equals to y plus 5, or y equals to minus x plus 2 whole square minus 5, or the inverse in this case for the function, inverse is a function here, will be, you could write like this, minus x plus 2 whole square minus 5. Clear? Now in this particular case, remember, as far as the function is concerned, x has to be greater than or equal to minus 5, and the y value, in this case, it is going down, right? It's less than or equal to 2. So here, when you write the function, you have to mention that in this case, for the inverse, x is greater than or equal to 2, and y is greater than or equal to minus 5. Is that clear? So note, you need to swap, so you have to mention domain and range, even if it is not required, since there is a restriction. Is that clear to you, right? Okay. Question number 3. So we have 4 parts, and these ones are not functions. So these are not functions. The first one is x squared plus y squared equals to 9, right? So I'd like you to pause the video, answer these questions. You will see that this one is a circle with radius of 3 units, correct? So in this particular case, inverse is not a function. It fails the vertical line test, crosses at 2 points. How do you find the inverse of this? Well, the inverse is we have to swap, right? So you could write what y is in this particular case, right? You need to find what y is. So if you swap, you get the same equation, in fact, okay. And then, no, the question is find inverse and state domain range of each relation, right? So, it is, you have to swap, so you get y squared plus x squared equals to 9, and you get y equals to 9 minus x squared square root with plus and minus, correct? So that becomes the inverse for you. Clear? This is your inverse. Now in this inverse, you can write down that your domain and range for the function is between plus and minus 3. Correct? So the domain here is that x is between minus 3 and plus 3, and y is also between plus and minus 3. Clear? So in both the cases, in this case, both domain and range are between plus and minus 3. Because of the symmetry of the circle, that is the domain and range for both function and its inverse. And both are not functions, right? Both are relations, correct? Okay. The second one is also a circle, right? This is also a circle. Now, in this case, when you swap, you will write this as y plus 2 whole square plus x square equals to 25. And you need to isolate y. So it will be what? It will be y plus 2 whole square will be equals to 25 minus x square, right? So now when you find the inverse, you can write the inverse, which is the y value, as equal to square root of all this and take away 2, right? So it will be plus minus square root of 25 minus x square minus 2. That becomes your inverse. Perfect. And you have to now mention what is domain and range. Similarly, you have to do these two parts. And once you do these two parts, then check with my solution. So I'm leaving it here for you to solve these questions, and then I would like you to check with my solutions. Okay?